Thank you, everyone. I'm delighted to be here. Just before Christmas, actually, we signed up as berth holders at Morlays, so hopefully providing a few pieces of the jigsaw puzzle, that analogy can run for a while. I can even probably tell you where they'd need to go on that jigsaw puzzle. But this is actually my first time with Orbital here at this conference, so I'm delighted to be here and have the opportunity to grow our network and the awareness into our business's vision of what tidal energy is and looks like, because I think you'll find it probably challenges some of the common assumptions that maybe has been worked to before. So just very quickly touching on the corporate background, it's a familiar story to everyone in this space. We are a startup R&D company, Scottish-based, with an office in Edinburgh and Orkney, close to the EMEC test centre. Over the 17 years since incorporation, we've accrued over 100 years of engineering expertise and know-how, how to do this technology, and obviously through that process accrued a lot of intellectual property. I would say that quite clearly stands us as the world leaders in the space of floating tidal energy. To cover that journey, we've had about 35 million pounds of investment, principally through equity, through a range of shareholders. You can see scattered along the bottom there in our journey, which also includes a number of milestones which back in 2011 the company was the first in the world to grid connect a floating turbine, which was a 250 kilowatt scaled unit, and in 2014 it started the build of a 2 megawatt unit, similar to that off the good performance of the first system, and that was launched in 2016 and started operation, and we'll cover off in the slides about where it's going, or how that indeed went. So this is the SR2000. If you're not familiar with it, fairly obviously a very different type of technology to what might be regarded as sort of conventional generation one, being floating now, where the analogy of generation one might be similar to wind turbines. I think our analogy is the technology is far more similar to a boat. So obviously the superstructure floats on the surface and provides the reference point for the rotors. We have two legs that come down underneath it, and it's obviously moored on site. It means that we can approach a number of the engineering challenges in a fundamentally different way, with the whole superstructure holding most of the power equipment and auxiliary systems. At 2 megawatts, it's the world's most powerful operating tidal turbine. It actually has two 1 megawatt turbines. It's fixed pitch, 16-meter rotor diameter, which is reasonably conservative actually, so stall regulated. It was manufactured in the Harland Wolff shipyard in Belfast. On the cranes there on launch, it was about 500, it was almost exactly 500 tons. And if we were to pull out fabricated steel as a proxy of levelized cost of energy, we have about just under 200 tons of fabricated steel per megawatt installed, which again, if you're drawing that as a comparison to some of the competing sectors like offshore wind, deeper offshore wind sites are now probably exceeding 300 tons of fabricated steel per megawatt installed. So some really compelling evidence of some of the conceptual benefits of floating tidal. So just following that through into the phases of the project, and drawing on the analogy with shipbuilding, that is effectively kind of what we're doing. So rather than this being an offshore construction project, it really is a shipbuilding. So we can do all the precision assembly, commissioning work in a safe, controlled environment of sheds and shipyards at quayside. And really, once that turbine is commissioned at quayside, it's ready to connect onto its moorings. So we simplify the offshore construction activities to the very familiar ones for the marine sector, which is installing anchors and chains and tethers ready to connect the turbine structure onto. And through that process, we can engineer out the dependency on high cost, low availability vessels that you can potentially, well, even at high cost, you should be careful about getting weaned on them around the North Sea sector, because you won't find them all the way around the world. So the vessel you can see in the picture here is what we call a multicat style vessel, kind of tractor of the sea. These contract at around about 3,500 to 4,000 pounds a day. So nothing was made more stark to me than the day that we installed the SR2000 in 2016 for the first time, where indeed this vessel turned up at 7 o'clock in the morning at Hatston Pier in Kirkwall to get the tow line of the SR2000, and by noon the turbine had installed itself onto its moorings. So if we'd been able to contract that vessel on an hourly rate, we would have installed the world's most powerful turbine for under £1,000. This is in contrast to bottom-mounted technologies using heavy lift jack-up barges where day rates can easily exceed £250,000. There's second-order benefits there around weather risk. So if that's not a stark enough, and hopefully you're not getting the jitters there with the picture, but if that's not a stark enough contrast, there is indeed very stark differences in terms of how we approach O&M. So the objective here for everybody has to be in the tidal space, especially with strong revenue streams, is generator uptime is a must. So we must maximize generator uptime. But we're presented with a dual challenge of minimizing costs. So we tackle O&M in a very different way to bottom-mounted technologies, who are generally tied to the infrastructure that installs them, very high costs. So the only way that the project economics really stack up is by making assumptions that you can achieve very long time between intervention. 5 years I've sort of seen. If we accept that we're actually using similar components to wind turbines, we really should be mapping the failure modes and the frequency interventions of wind turbines onto our own technology. And that certainly isn't once every 5 years. But we de-risk the entire thing by ensuring the consequence of intervention can be very low cost and very quick. So what you see here is the type of vessel that we use, low cost ribs, under £1,000 a day, that allow our team to get very quick access to the turbine to make a fixing. Oh, there is a bit. That's the noise of tidal power, by the way. So you're sat on the driver's seat here of the SR2000. The nose is starting to go down under the water with thrust coming on, so we're probably getting close to 2 megawatts here. And there's a conceptual benefit there as well. Using the surface of the sea as your reference point, of course, is that closest to the sea surface is where you get the most laminar, fastest flowing regions of the tidal resource. So we're exposed to the best resource, so we're using best use of all the equipment. There are other benefits technically as well, of course, because we're hanging from the surface, we're at shallower depths, so pressure rating, water is not being tried to be squeezed into our turbine with ever-increasing depths as you're on the seabed. And indeed, we're rather indifferent, or we are entirely indifferent to the seabed depth. Going to deeper water only means adding a bit of chain length into our moorings. So what did the SR2000 manage to do for us? Over the last year and a half, I'd argue that it's completely validated the key cost and performance parameters with unparalleled prototype success. In a short time, we actually exceeded the 2 megawatt rating and got to 2.2 megawatt output. There's more power has come out of any marine turbine in the history so far. The SR2000 on its site here in EMEC in Orkney has, with its short blades, has a theoretical gross capacity factor on an annual basis of around about 25–26%. We managed to achieve over 50% capacity factors in single tides, 45% capacity factors sustained over 24 hours, 40% capacity factors over a week. The best single month, 314 megawatt hours and a 24% capacity factor. And the turbine took less than 16 weeks to generate its first gigawatt hours. In total, over its first year of continuous operation, the turbine generated 3.25 gigawatt hours. And if we allow for a thermal constraint that we had at EMEC's substation, it works out around about 20–21% capacity factor net of maintenance and inspection outages. And that included taking 2 weeks off at Christmas to give everyone a break, because that's the way we party in Scotland. But the statistic was that in 12 months, the SR2000 generated more power in 12 months than the entire wave and tidal sector in Scotland had cumulatively achieved in the 12 years preceding the SR2000's launch. During a sample week, the turbine met over 7% of the entire electricity demand of the Orkney Islands, which has over 20,000 residents, inhabitants, running businesses and their homes. At times, the turbine was generating more than 25% of the local demand. We managed to maintain continuous generation approach in seas approaching 4.4 meters significant wave height. We maintained rated power in 2 meter significant wave height, and we withstood storm conditions of over 6 meters. In 380 days of continuous attestment, where the turbine saw over the equivalent of over 60,000 kilometers of water pass it by, each nacelle generated for over 7,500 hours. We only used low-cost vessels in this period of under £1,000 a day and achieved a minimum intervention time of 31 minutes from quayside to turbine. Close to 3,000 hours was accrued working offshore, with almost 240 ship-to-turbine transfers with no lost time incident. So that's what we've done. And as I said, I think it's an appropriate title that we refer to the SR2000 as an industry breakthrough project. But what are we doing is probably a more pertinent and exciting question. So we haven't been sitting on our hands for the last 2 or 3 years. We've been incorporating all the learning and experience that we've got through the build and the operation of the SR2000 into an optimization process. We also changed our name towards the end of last year, so everything's changing. We went from Scott Renewables to Orbital Marine. This turbine is now the O2. It incorporates key innovations to improve yield on a like-for-like basis. This will generate 50% more power, although effectively weigh the same as the SR2000. And it's been optimized for lower cost manufacturing and cost reduction. So this is just a short video of what it's all going to look like. So we've been very careful not to throw out all the unique selling points that have served us so well through the SR2000, whilst being bold to tackle some of the design issues that we could see that were going to create commercial exposures for us. Some of the big ones that you can quite quickly see are around the actuation and of the legs themselves. So rather than tucking up underneath the turbine, they now come up to the side in a gull wing type of actuation, which means that we can get easy, low-cost access to nacelles and pitch systems. We are incorporating pitch system into this, so we're moving from stall regulated. That's enabling us to increase the yield. That 50% like-for-like increase is with a swept area of 20-meter rotor diameter. That pitch system actually can now serve a dual function. The SR2000 was moored at its nose and had a yawing capability around a turret structure, which was quite a complex, expensive arrangement and limited our electrical infrastructure to 6.6 kV. The pitch system can now allow for the fact that tide only comes from you for 2 directions. So the machine can be simply moored forward and aft, and the pitch system just allows for that to change the blade shape. And of course, critically, the system is highly accessible. We've a minor change. We've changed from vertical ladders, which created confined space and then led to all sorts of health and safety complications and knock-ons, to even having a staircase here and welfare facilities. So this is the Orbital O2, and this is what we believe will be, and are confident is our product, our commercial product offering. And just on a final note here, just to draw together probably a number of comments and threads that have come from speakers on the floor recently. Last year, we took the bold step of challenging the conventional funding model here in this stage in a way. We moved to crowdfund the project from a project financing perspective. So we worked with the Abundance platform in London. In October, we opened a debenture bond there with a target of 7 million, and we reached that in 12 weeks. Actually, on New Year's Day, I think it reached it. That is the UK's largest single ever crowdfunded debenture bond to date. So I think from us, it's a huge endorsement of our vision and our achievements with our technology, but hopefully for the tidal sector at wider here, it demonstrates a different avenue that we can look at engaging the public, but indeed that public is engaged, and it is excited and it's enthusiastic, and it wants to see this industry and these technologies happen here in the UK. Thank you.